The National Electrical Code, or NEC, addresses the conditions under which conductors of different voltage systems are permitted to occupy the same raceway. Section 300.3b of the NEC specifically allows conductors of different systems, voltages, or circuits to occupy the same equipment or raceway. However, this permission comes with a crucial stipulation: all conductors must be insulated for the maximum voltage present in the raceway. This requirement ensures that the insulation of each conductor is capable of withstanding the highest potential difference that could occur between any two conductors within the raceway, thereby preventing insulation breakdown and potential electrical faults. To understand the implications of this rule, let's consider a scenario where both 120/208 volts and 277/480 volts systems are present in the same raceway. The 120/208 volt system is commonly found in residential and commercial buildings for lighting, receptacles, and small appliances. The 277/480 volt system is typically used in commercial and industrial settings for powering larger equipment, such as HVAC systems, large motors, and industrial lighting. According to NEC Section 300.3b, if these two voltage systems are run in the same raceway, all conductors, including those of the 120/208 volt system, must be insulated for at least 480 volts, which is the maximum voltage present. This means that the conductors used for the 120/208 volt system must have an insulation rating of at least 600 volts, as this is the standard insulation rating readily available and commonly used for both 120/208 volts and 277/480 volts systems. Several factors are at play when determining the appropriate insulation for conductors in mixed voltage systems. Firstly, insulation breakdown can occur if the insulation is not rated for the voltage applied. This can lead to short circuits, ground faults, and potentially fires. Secondly, the NEC aims to minimize the risk of electrical hazards by ensuring that all components of an electrical system are adequately rated for the highest voltage they may encounter. Thirdly, using conductors with a higher voltage rating than required for the lower voltage system provides an additional safety margin. This practice can help to prevent insulation degradation over time due to factors such as heat, moisture, and physical stress. It's important to note that while NEC Section 300.3b permits the mixing of different voltage systems in the same raceway, other NEC articles may impose additional restrictions or requirements. For example, Article 310 addresses conductor ampacity and derating factors. When multiple conductors are installed in a raceway, their ampacity may need to be derated to account for the increased heat generated by the conductors. This derating is particularly important when conductors of different sizes and voltage levels are present in the same raceway, as the larger conductors carrying higher currents may generate more heat, affecting the ampacity of the smaller conductors. Furthermore, Article 314 covers outlet boxes, device boxes, and pull boxes. These boxes must be sized appropriately to accommodate the number and size of conductors installed within them. When mixing different voltage systems, it's essential to ensure that the boxes are large enough to provide adequate space for the conductors and their connections, preventing overcrowding and potential damage to the insulation. In addition to these general requirements, certain specific types of systems may have their own unique requirements. For instance, Article 725 addresses Class 1, Class 2, and Class 3 remote control, signaling, and power limited circuits. These circuits have specific voltage and current limitations and may be subject to additional restrictions when installed in the same raceway as other power circuits. Similarly, Article 760 covers fire alarm systems, which are critical for life safety. Fire alarm circuits must be installed in accordance with specific requirements to ensure their reliability and functionality during a fire. When these circuits are installed in the same raceway as other power circuits, additional precautions may be necessary to prevent interference or damage to the fire alarm system. To comply with NEC Section 300.3b, several practical steps should be taken during the design and installation of electrical systems. Firstly, carefully identify all voltage systems that will be present in the raceway. This includes not only the nominal voltages but also any potential voltage fluctuations or transients that may occur. Secondly, select conductors with an insulation rating that is equal to or greater than the highest voltage present in the raceway. As a general rule, conductors with a 600 volts insulation rating are suitable for most applications involving 120/208 volts and 277/480 volt systems. Thirdly, ensure that all conductors are properly identified and labeled to indicate their voltage and function. This helps to prevent confusion and accidental contact with live conductors during maintenance or troubleshooting. Fourthly, follow all applicable NEC requirements for conductor ampacity, dating, and box fill. This ensures that the conductors are not overloaded and that the boxes are not overcrowded, preventing overheating and potential damage to the insulation. Fifthly, use appropriate wiring methods and installation techniques to protect the conductors from physical damage and environmental factors. This includes using conduit cable trays or other suitable raceways to protect the conductors from abrasion, moisture, and sunlight. Lastly, thoroughly inspect and test the completed installation to verify that it complies with all applicable NEC requirements. This includes performing insulation resistance tests, continuity tests, and voltage drop tests to ensure that the conductors are properly insulated, connected, and sized. In summary, NEC Section 300.3b permits the mixing of different voltage systems in the same raceway, provided that all conductors are insulated for the maximum voltage present. This requirement is intended to ensure the safety and reliability of electrical systems by preventing insulation breakdown and potential electrical faults. To comply with this rule, carefully identify all voltage systems, select conductors with an appropriate insulation rating, follow all applicable NEC requirements for conductor ampacity, dating, and box fill, and thoroughly inspect and test the completed installation. By following these steps, electrical professionals can safely and effectively install mixed voltage systems in accordance with the NEC. To further elaborate on the practical implications of NEC Section 300.3b, let's consider some specific examples of how this rule applies in different types of electrical installations. Firstly, in commercial buildings, it is common to have both 120/208 volts and 277/480 volt systems present. The 120/208 volt system is typically used for lighting, receptacles, and small appliances in office areas, retail spaces, and restaurants. The 277/480 volt system is often used for powering HVAC systems, large motors, and industrial lighting in mechanical rooms, warehouses, and manufacturing areas. In these types of installations, it is often more convenient and cost-effective to run conductors of both voltage systems in the same raceway, rather than installing separate raceways for each voltage system. However, to comply with NEC Section 300.3b, all conductors in the raceway must be insulated for at least 480 volts. This means that the conductors used for the 120/208 volt system must have a 600 volts insulation rating, even though they are only carrying 120 or 208 volts. Secondly, in industrial facilities, it is even more common to have a wide range of voltage systems present. In addition to 120/208 volts and 277/480 volt systems, there may also be 480 volts delta systems, 600 volt systems, and even medium voltage systems operating at several thousand volts. In these types of installations, it is essential to carefully identify all voltage systems and select conductors with an insulation rating that is equal to or greater than the highest voltage present in the raceway. In some cases, it may be necessary to use conductors with a higher insulation rating than would normally be required for the specific voltage system. For example, if a raceway contains both 480 volts and 600 volts conductors, all conductors in the raceway must be insulated for at least 600 volts. Thirdly, in residential buildings, it is less common to have multiple voltage systems present. However, there are still situations where NEC Section 300.3b may apply. For example, in some homes, a 240-volt system may be used for powering large appliances such as electric ranges, clothes dryers, and air conditioners. In addition, a 120-volt system is used for lighting, receptacles, and small appliances. If conductors of both voltage systems are run in the same raceway, all conductors must be insulated for at least 240 volts. In most cases, this requirement is already met, as conductors used for residential wiring typically have a 600 volts insulation rating. It is also important to consider the impact of NEC Section 300.3b on the selection of wiring methods. The NEC defines a variety of wiring methods that are permitted for use in different types of electrical installations. These wiring methods include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit, non-metallic conduit, and cable trays. When mixing different voltage systems in the same raceway, it is essential to select a wiring method that is suitable for the highest voltage present. For example, rigid metal conduit and intermediate metal conduit are typically suitable for use with both 120/208 volts and 277/480 volts systems. However, flexible metal conduit may not be suitable for use with 277/480 volts systems in all cases, as its voltage rating may be limited. Similarly, non-metallic conduit may not be suitable for use in certain types of installations where there is a risk of physical damage or exposure to high temperatures. In addition to selecting an appropriate wiring method, it is also important to follow all applicable NEC requirements for the installation of the wiring method. This includes properly supporting and securing the raceway, using approved fittings and connectors, and ensuring that the raceway is properly grounded. By following these requirements, electrical professionals can ensure that the wiring method provides adequate protection for the conductors and that the electrical system is safe and reliable. Furthermore, it is crucial to consider the impact of NEC Section 300.3b in the selection of overcurrent protection devices. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. When mixing different voltage systems in the same raceway, it is essential to ensure that the overcurrent protection devices are properly sized and rated for the specific voltage and current of each circuit. For example, if a raceway contains both a 120-volt circuit and a 277-volt circuit, each circuit must have its own overcurrent protection device that is rated for the appropriate voltage and current. The 120-volt circuit breaker must be rated for 120 volts, and the 277-volt circuit breaker must be rated for 277 volts. In addition, the overcurrent protection devices must be sized to protect the conductors from overloads and short circuits. The size of the overcurrent protection device is determined by the ampacity of the conductor. The ampacity of a conductor is the maximum amount of current that the conductor can safely carry without overheating. The NEC provides tables that list the ampacity of different types of conductors based on their size, insulation type, and installation conditions. When selecting overcurrent protection devices, it is important to consult these tables to ensure that the devices are properly sized to protect the conductors. It is also important to consider the impact of derating factors on the ampacity of conductors. As mentioned earlier, when multiple conductors are installed in a raceway, their ampacity may need to be derated to account for the increased heat generated by the conductors. This derating is particularly important when conductors of different sizes and voltage levels are present in the same raceway, as the larger conductors carrying higher currents may generate more heat, affecting the ampacity of the smaller conductors. When derating conductors, it is important to follow the NEC requirements for derating factors. The NEC provides tables that list the derating factors for different numbers of conductors in a raceway. These tables should be consulted to ensure that the conductors are properly derated and that the overcurrent protection devices are properly sized. In addition to these general requirements, there may be other specific requirements that apply to the selection and installation of overcurrent protection devices. For example, Article 240 of the NEC provides detailed requirements for the protection of conductors from overcurrent. This article covers a wide range of topics, including the selection of overcurrent protection devices, the location of overcurrent protection devices, and the coordination of overcurrent protection devices. When selecting and installing overcurrent protection devices, it is essential to consult Article 240 to ensure that all applicable requirements are met. Finally, let's consider the impact of NEC Section 300.3b on the inspection and testing of electrical systems. After an electrical system has been installed, it is important to inspect and test it to ensure that it complies with all applicable NEC requirements. This includes verifying that all conductors are properly insulated, that all connections are properly made, that all overcurrent protection devices are properly sized, and that the system is properly grounded. When inspecting and testing electrical systems that contain mixed voltage systems, it is important to pay particular attention to the insulation of the conductors. The insulation should be inspected for any signs of damage, such as cracks, cuts, or abrasions. In addition, the insulation resistance should be tested to verify that it meets the minimum requirements specified in the NEC. The insulation resistance test is performed by applying a high voltage to the conductor and measuring the amount of current that leaks through the insulation. The higher the insulation resistance, the better the insulation is performing. If the insulation resistance is below the minimum requirement, the conductor must be replaced. In addition to inspecting and testing the insulation, it is also important to verify that all connections are properly made. Loose connections can cause overheating and arcing, which can lead to fires. All connections should be tightened to the proper torque specifications. In addition, the connections should be inspected for any signs of corrosion. Corroded connections can also cause overheating and arcing. If any signs of corrosion are present, the connection should be cleaned and retightened. It is also important to verify that all overcurrent protection devices are properly sized. This can be done by comparing the size of the overcurrent protection device to the ampacity of the conductor. If the overcurrent protection device is too large, it will not protect the conductor from overloads and short circuits. If the overcurrent protection device is too small, it will trip unnecessarily. Finally, it is important to verify that the system is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock. The grounding system should be inspected to ensure that all connections are properly made and that the grounding conductors are properly sized. In summary, NEC Section 300.3b is an important rule that allows for the mixing of different voltage systems in the same raceway, provided that all conductors are insulated for the maximum voltage present. To comply with this rule, it is essential to carefully identify all voltage systems, select conductors with an appropriate insulation rating, follow all applicable NEC requirements for conductor ampacity, dirting, and box fill, and thoroughly inspect and test the completed installation. By following these steps, electrical professionals can safely and effectively install mixed voltage systems in accordance with the NEC. The allowance of mixing voltage systems offers efficiency in installation, reduces material costs, and optimizes space within a building's electrical infrastructure. Understanding and adhering to NEC Section 300.3b, along with all referenced and related articles, is crucial for ensuring the safety and reliability of electrical systems. Always consult the latest edition of the NEC and seek guidance from qualified electrical professionals for specific applications and interpretations.